Marek from McNeel Europe, and I want to welcome you to a new food4Rhino webinar. Today we are presenting Lattice General Studio. This is a new Rhino plugin that allows you create lattice structures thanks to its Neubs Voxel modeling capabilities. And we have with us Marek Moffett from the company. He's located in Chicago, United States. And Marek is a co-founder of General Lattice, and he also led the team that developed GL Studio and this Neubs Voxel modeling methodology. During the webinar, please feel free to use the chat. My colleague Carla Sologuren is there, so she will be answering any questions she can. But for direct questions for Marek, we will collect this, and then at the end of in the final part of the webinar, we will place these questions to Mark. Also remember that this webinar is being recorded, so it will be available right now, right after it finishes on our YouTube channel. And yeah, Marek, thanks for being here. You can now start with the presentation. We have more than 50 concurrent viewers so far. I think it will be a great webinar.
Awesome. Carlos, thank you for having me. I just wanted to give a special thanks to the whole McNeel team, and especially Dale for putting up with me and the development team over the development period of GL Studio. So with that, again, I'm Marek Moffett, Chief Innovation Officer at General Lattice, and I'll give a quick background of the company. So General Lattice, we aim to develop and build the next generation design, optimization, and manufacturing tools. And we started out with that by developing a lattice design toolkit that develops lattices in true BREP data, all within your favorite CAD tool, which eliminates a lot of the expensive import-export process. And General Lattice Studio came about. General Lattice was founded in 2018 with myself and Alex and Nick, the two other co-founders. And we started off doing a lot of lattice development work for consulting base. And what we quickly found is a lot of these customers wanted access to our tools so they could take these tools internally and work on IP they didn't want to share with us. And so that's where General Lattice Studio comes from. And so next I'll cover what General Lattice Studio, the technology it's built on, and that is something we call Neubs Voxel modeling. And it works in 5 main stages. You start off by generating a wireframe, and you can see depicted in here is an example of this pink wireframe. You can adjust and manipulate that wireframe in all 3 axes, X, Y, and Z, so you can add the amount of cells or voxels you would like, and you can shift them along their axis. Next step is you choose a shape that you want to be patterned within each voxel. And so in this example here, you can see this blue shape in the corner with the voxel wireframe around it. That's a Schwartz cell. And that's what's being repeated over and over again. You can see on the right side of the shoe, and that's what happens when you map the cell. And then once it's thickened, you have a fully solid body BREP structure that now can be manipulated and Booleaned and perform your normal CAD operations on. And so today, I'll take everyone through downloading, installing General Lattice Studio. I'll do a tool overview. I'll cover some workflows of how to use Lattice Loft. Then I'll do a quick application example of being a midsole. And then I'll just show how to prepare that midsole we create for printing and export. So to an STL, if we're going to 3D print it, and showing the various export options, step, parasolid, to get it into other applications as need be. And then at the end, we'll have a 20-minute Q&A, which Carlos was talking about. So I'll exit the share here, and we'll go to food4Rhino. And we'll go and you can either search for GL Studio, or it should be on the front page here. And assuming you're logged in, you can go and download, and you should be able to download the beta here. And when you download, it should take you to this page, and we'll have you fill all of this out. Make sure you select your correct operating system, and please be sure to check both of these boxes. And when you do so and click download plugin, you will get the downloading package, which is a Rhino installer file, and you'll also get a license key. That license key will also be emailed to you. So once you've downloaded the files, I'll let you guys sort of work through that here. I wanted to show generallattice.com, GL Studio. You can also find a download there. You can also find our user manual. And if you go to our user manual, it takes you through a lot of the basics of installation and the overall goals of our tool. And there's also, more explanation in the user manual about each UI and which each button is controlling what. And it goes through each unit cell geometry to get a better explanation about it. And then we also finally have some videos at the end, which are some really awesome videos on top of this webinar, which can help you get started. So once you guys can poke through those, you've downloaded the Rhino installer, quit Rhino, and all you'll do is double click the Rhino installer file, and you'll walk through that, and the plugin will be installed. Next time you start Rhino, we'll type in Lattice Loft. And so if this is your first time launching Lattice Loft, it'll prompt you for that license key. And that's where you will enter this license key. And once you hit enter, it should give you access to our modal here. Great. So assuming, give a few more seconds here to let everyone enter their license key and install Lattice Loft. I'll walk through a few demos of how to use our tool within a few sets of surfaces. And so how Lattice Loft works is it always needs at least 2 surfaces. And so in this instance, I have 2 cylindrical surfaces, and I'll select both of those and hit enter. I'll turn the preview of those surfaces off. And this is our Voxel wireframe, or our Voxel preview, the first step in our Neubs Voxel modeling methodology. And you can see as I manipulate the X cells or Y cells, that's increasing the amount of voxels in each axis here. And so this voxel wireframe serves as a visual representation of what your lattice is going to look like when the cells are mapped into each individual voxel. And so here you can quickly explore, if you want a gradient from the top to the bottom, what these structures can look like. And so kind of like this, I've got a gradient going towards the bottom. I'll push that up. I'll increase my fins here. And so now we'll go to the unit cell tab. Under here, you'll find our different cell families. So TPMS, member, and custom. We'll start with a TPMS, and we have a Schwartz cell here, and I'll hit generate. You can see it spits out a wire preview, which can be difficult to see depending on what you're looking at. The reason we do this is to save computational time. You can always click the shaded preview. That will be a bit heavier, but will give you a better look of the structure you're dealing with. And so I like what I'm working with here, and I'm going to thicken it 0.5 millimeter. And so when I hit thicken, we'll wait for the yellow feedback, which means the structure has been thickened. And we can actually take a look at it as shaded as well. Very thin. I actually want to keep that like that. And so I'll hit done. And when you hit done, the structure will be baked or set to the Rhino viewport. And now we have a single closed polysurface here that we can manipulate and do our Booleans and what have you. And we'll just make sure it's a closed polysurface, and it is. So that was a quick example of how to use just 2 surfaces. And what's really exciting too is the way you can iterate quickly through very similar structures by just slightly manipulating my underlying surface geometry, I'll now get a quite different result when I generate my structure just by sort of rotating that surface. And you can see, you know, I now have this sort of spiral sort of fin as opposed to an aligned one, and we can map a lattice to this as well. We'll go the other way. We can do a gyroid and we'll hit generate. And you can see the more complex a structure may be, it may be more difficult to see. And so that's where the shaded really comes into play. And I like this. We'll do the same thing where we'll thicken it 0.5 millimeter. And depending on the complexities of your structures, the time spent to, you know, do complex operations can depend. It's something we're actively working on, but we're really excited at the speed at which these cells do these complex operations. And so now we have a closed gyroid body that we could also manipulate as well. Great. So with that, I'll move to a next example of how to use our tool here. And previously I used just a pair of surfaces, so just two, but very similar to the Rhino Loft command. If you put in more than two surfaces, you'll get curvature with trying to interpolate between those. And so I can show that by selecting the surfaces in the order on which I want them to generate, and we'll get our wireframe preview. And so we can see, we can start to manipulate the structure. I sort of like the 2x2, and now we can start to adjust our cells in the Z. And what's something interesting to note here is that the amount of cells in here does not change the shape of the voxel wireframe generated. And so I'll keep something like this. And let's do the Schwartz, and we'll hit generate. Great. And we'll thicken at 0.75. And so we'll hit thicken, and we'll wait for our yellow feedback. We'll hit done. And so here, again, you can see we have complex curvature in all axes. Again, sort of just by simply adding the amount of surfaces along that path you wanted to interpolate. Great. The next one I'm going to show, I'm going to use this same set of surfaces, and I'm going to use a different type of unit cell. It's our custom unit cell. So it's the ability for the user to actually select geometry from the viewport, and our tool will map that accordingly. And so let's create a similar structure again here. Maybe give it a bit of a gradient. And let me turn on this sphere I've created. And so when we go to map a custom cell, it can accept meshes, open or closed, or B-reps, open or closed. And we didn't want to limit the user on being able to map or manipulate a mesh cell or structure they wanted to pattern if they have that. But the true power is being able to create them in B-rep structure. So that being said, we'll go to custom unit cell under the unit cell family, and we'll click select from viewport. And you can see that the toolbar prompts you to select your cell. We'll select the sphere, and I'll hit enter, and I'll hit generate. And you'll notice that the tool recognizes that the surface is closed, and so it does not give you the ability to thicken this surface. And so if you gave it an open surface to map, it would give you the ability to thicken. And so we can take a shaded preview, and we can see that we have now taken a custom shape that was generated in Rhino, and it can be mapped to our NVM technology. So we'll hit done, and there's our structure there. All right. So for the next example here, I want to move into a more realistic application, being a midsole, which seems quite popular in the latticing community. And so here I just have three, an outsole and a sole, and then one I've tweened in between. And we get a lot of questions about how to create a single surface of this complexity from a single profile. And so I wanted to show that really quick. And so all I've done here is taken the profile of this top shoe and I've just projected it to the C-plane. And so I'll sort of start this over. I'll join these back together. And so this is the profile of this surface projected to the C-plane. And so when you now have this profile, a really great technique to creating a single surface out of it is to create a network surface. And so the goal here is to be able to split this profile into 4 segments that the network surface can see as its 4 sides. And so we'll do that with a simple split command. We'll select our profile, hit enter, and select the 2 curves we would like to split this profile. We'll hit enter. That should spit out 4 separate curves that profile is now split into. And so we'll run the network surface command and we'll hit no auto sort. And so what we want to do is select the curves in U and V, or up and down, or left and right. And so we'll go 1, 2, 3 and hit enter to go for the next direction. And then we'll select 1, 2, and 3. And we'll hit OK. And so now we have a single surface matching this profile that will work great with our tool. And so just for the sake, I'm going to rebuild this surface. And you can see it has quite a lot of data. I'm going to reduce that because I am not too concerned with it to be perfectly matching that profile. Yeah, and that looks really good. And so with this technique, you can turn points on and you can start to manipulate this structure. And so if you can imagine you wanted to make a sole that matched, a certain profile, or just even wanted to add, an arch or some organic to that, you can start to manipulate these points, and rebuilding them to amount that allows it easier to manipulate can be done. But that's essentially the technique I have used to create these 3 surfaces. And so with that, once you've created that surface profile, again, I've just sort of duplicated them and then begin to sort of sculpt them with having some raises here and a dip in the heel as well, and maybe exaggerate some of that. And so that's a really common technique that we use, is to create complex profiles, the single surfaces, and then start to add curvature to them. And so let's actually start to lattice this. And so what we'll do is launch Lattice Loft. And we'll select our surfaces again in the order. And let's turn these guys off. Maybe we'll keep the bottom one on. Great. And so now we can start to control these structures and get a visual representation of what this may look like. And so we can start to shift things certain ways, give gradients certain ways, and really start to explore this shape. Maybe flattening it towards the sole would give more of a cushion, while these cells down here would be stronger. And so you can quickly, start to understand what this shape may look like. And so I'll keep something like this, maybe turn a bit more up on this axis, keep it pretty uniform. And so we'll keep the Schwartz, it's my personal favorite. And you can see how it quickly maps, and say you don't like this looks too uniform, you can easily go back and actually start to increase or decrease without starting the whole process over, which is very nice when starting to explore different iterations very quickly. And so sort of like the gradient towards the heel, towards the ball of the foot. And so we'll keep that and we'll go back, we'll hit generate again. Great. And so we'll thicken at 0.5 mil. We'll hit done. Awesome. So now we have a structure that is conformal through these surfaces. In using this third middle surface, we get the curvature around the side. It's except, just the surface to surface, which it would be planar all the way around the edges, and aesthetically not terribly pleasing for a midsole. And so I've actually have a lattice already generated, this pink one with the same surface data. And so what's really exciting about having BREP data is that you can now start to manipulate this shape and as you would any other solid or surface data. And so what I ended up doing was creating a surface where a duplication of the black surface here. And I just split that surface doing a simple split command. And it mapped to the lattice perfectly. And so we now have these sort of holes where the lattice exists. And so with this, if you wanted to create a sealed lattice for whatever reason, maybe on the top or the bottom, you can now do split commands with them. You can do Boolean intersections. And so with that data, I have created a sole surface here that sits on top of the lattice, but still would allow airflow to the sole of the foot is the concept. And I'll show now how I want to put a brim on this concept. And so what I've done is extracted the edges of these three surfaces, the black, the white, and the gray. And so I'll just recreate this. And these are the edges of each of these surfaces. And so you can see that it's their border. And so what we'll do is a loft command. And we'll select uniform and keep all this aligned, and we'll hit OK. And so now we have a poly surface going all the way around our structure that you can see. It sticks out a little bit because of the thickness, and I'll show how to address that. So I'm going to end up thickening this surface, which I have right here, as I just did an offset surface command. And I now have a poly surface as a brim and the lattice in the middle. And so what we can do is take these, and I want these to be one piece, and we'll just do a simple Boolean union. And so now we have a single body closed poly surface, which can very seamlessly be able to be translated to mesh that can now be explored with other and surface and solid data, can be cut, subtracted, turned to an STL if needed. So this is something that's really exciting, and this is something that can be exported. So if we do file export selection as, we'll just do a generic step file. This technique can easily be imported to your favorite CAD platform if need be, or translated into some sort of FEA for mesh refinement or mesh preparation. Another option to pass this to 3D printing, which is really exciting for us, is since it is a single closed body, we can simply use Rhino's mesh from Neubs object. Depending on the quality you want, you can hit OK. And what we'll return is, let's select closed mesh. And so now we have a mesh that is watertight and ready to be printed. And so let's do the export process for something like that. And we'll do an STL. Great. We'll do a shoot test. And I just wanted to show the simple workflow and that, it creates closed meshes. I'm using Repetier host, an open source slicer, and we'll do load file. We'll do our shoe test. And it brings it in as a closed mesh, no problem, that is now ready to be sliced with your favorite slicer and put on your favorite machine, whether it be FDM or liquid or what have you. So back to Rhino. I wanted to show one other technique that is sort of widely used in the community and can be crude, but can also be extremely useful. So similar to creating a lattice through 3 different surfaces, such as we see here. Remove the brim. This technique is great and can be used for lots and lots of different applications. But another technique, as again, the community has seen quite a bit, is known as the Boolean intersection technique. And that would be the concept of throwing a bounding box around all of the geometry you want to lattice, and then subtracting that lattice. And so I have that prepared and I can show is, here's a version of, I've got the lattice in it, let me hide it. So this is a closed volume, a solid body of those surfaces I created and the brim added to it. So essentially just a solid version of what we were creating earlier as a lattice. And so with this technique, I simply created this one surface on top and a surface on the bottom, and those being our bounding box or bounding rectangle that completely covers that closed volume. And so I simply generated a Schwartz about 1 millimeter thick. And a really effective technique is to do a Boolean intersection. And you can select your polysurface, the closed volume, and then the polysurface lattice and hit enter. Oh, I apologize. First, select your first set, hit enter, select your second set and hit enter. And now the intersection is working. And again, depending on the complexity of your parts, depends how long this can take. But you can see, I wanted to show the potential benefits or not of this technique is that, again, depending on your geometry, it can create a lot of unwarranted instances. So for example, we have sort of a floating shape here, which, could easily be deleted or joined to something else, but you don't have as much control over creating solid voxels because you're cutting away those voxels. But again, nonetheless, still a really useful technique. And I've also got an example of a different cell as well, using the Neovius inside of that same shape here. And so again, the power is, this is still a closed B-rep that can be imported and exported and manipulated any way you may imagine. Yeah, and so, okay, that's covered pretty much all of the midsole. I wanted to just cover a few extra useful modeling techniques that may be sort of not obvious with the tool, and that would really empower a lot of different exploration. And so I'll bring our cylinder surfaces back up, and I'll do a lattice loft again. I'll select these guys. And so when I start to create my structure, that looks good to me. Let's go to the member side. And so you can see here, we have quite a bit different types of lattices that may be used in the member side. They're really exciting and pretty intricate shapes that are quite different from the shell-based lattices. And something I wanted to show is if you, for whatever reason, need to use the curve data of our structures, a really useful technique is to actually put in a thickness of 0, and you hit thicken and hit done. You now have the curve network to be able to manipulate and do whatever have you with. Bring those same surfaces back up. Same thing goes for our TPMS surface-based structures. If you create geometry that for whatever reason, say you didn't want to thicken them, you wanted just their surface data, you can also come in and hit 0 and hit thicken. And when done, you should have this surface data. Great. And so you now have unthickened surface for whatever reason you may want. And again, these can all be used with traditional Rhino commands just as usual. And Carlos, I think that's about it I have for the demo. I'd be ready for some questions.
Great, nice demo.
Thank you.
I don't know, excellent, very instructive. And yeah, there are a few questions already. I don't know if you wanted to show also that Grasshopper definition, even if you don't have any Grasshopper components yet.
Sure.
But as the question arises.
Sure. No, that's a great point. Yeah, give me 1 second. I'll pull up Grasshopper here. Actually, GL Studio is actually developed in Grasshopper. All of the methodologies were developed within Grasshopper, and our first MVP was in there, and we used human UI to do all these things, and absolutely fantastic tool. And so as a company, we recognize the power of Grasshopper and will be released in our full release of GL Studio, which is coming soon. And so let's see, I can start to demonstrate the power of when pairing Grasshopper with GL Studio. And this isn't even giving access to our Grasshopper modules for GL Studio. This is just using native Grasshopper components to sort of just add efficiency and add functionality to GL Studio. And so how this quick little script works that I've done is it takes a curve. And so I'm just going to draw a curve anywhere in Rhino's viewport. I'm going to select, I'm just going to make this a bit of a complex curve. Start dragging some control points. You can see it's quite complex. And so what I'll do is I'll select this curve and I will set one curve. And so now what the script is doing is placing surfaces along this curve, and I'm scaling them along the curve. So not only do I have position control along this curve where I'd like the surfaces, I also have the amount to increase the resolution of my curvature. And then I can also control the size of these surfaces being tweened through. And so what I'll do is I'll just simply bake these surfaces to the viewport. And they'll be baked as a group, which is really nice for the tool. And so when you launch Lattice Loft, I'll maximize Rhino. Apologize, let me minimize Grasshopper. So when you launch our tool, you can just select them as a group. Oop, I apologize. Select them as a group and highlight them and hit enter. And you now have curvature through all these surfaces, which would be quite of a pain to go in place and get their normals aligned along this curve. And so it's something we're pretty excited about to really add this sort of lattice control through curves, which can add a lot of functionality to existing CAD data. And so you can start to see some exploration of this here. And again, just sort of reiterating that Grasshopper components are coming soon, and in the full version, and we're very excited for the amount of control and true complexity that it gives to our tool. This sort of the goal of this first Rhino tool was sort of to democratize the ease of exploring these complex structures, but those Grasshopper modules will take it to the next level to give that extra muscle to the people that want that level of control. And let's see, do circle, round. Great.
Excellent, thank you.
Yep.
Yeah, well, we want to remember all the viewers here that this is still in beta, right?
Yep.
So right now it's free to download from food4Rhino. And well, we had up to 180 concurrent viewers. I think it's so far the most successful webinar. And during the next days, it's being recorded. I'm sure many more people will watch it from our YouTube channel.
Awesome.
We have people from everywhere, and we have a few questions.
Sure.
For example, first one. Okay, one guy asked where to download it from. Carla already put the link there.
Great.
And yeah, Andre Kuipar says where the ball was used as a lattice example. So when you use that spheres, if they can be joined one into other. Otherwise, there is no thickness on the touching points.
Correct. So that's a good question. And so let's see if I can maybe give a quick example. But so how the custom unit cell works is it bases it off of its symmetry. So a good way to think about it is if you just create a simple box in Rhino, and I'm just going to hit enter to make sure I use the same size on all aspects. And so I just have a simple box. And if you build your geometry within a box, that will create the perfect replication over and over, assuring connections between points. So I think what you're getting at is, since the sphere technically just has vertices touching on each sides. And so if you went to join those together, they're technically just touching at vertices, so they probably would not union together. That being said, if you design your unit cell accordingly, or within this box, or optimize for GL Studio, you could get pretty much whatever you want to union back together.
Okay. So one more questions here. Yeah, well, Anthony was asking where to find the Lattice Loft command, and we answered already that first, this is a plugin. He needs to download it and install it.
Great.
I mean,
great.
With new plugins, there are new commands added to Rhino.
Yep.
Also, yeah, Yasin asked if if there is a Grasshopper version. You already answered, not yet, but you show a workflow using Grasshopper.
Yep. And I'll I think we talked about this, Carlos. We'll include that Grasshopper script somewhere within the download link, so it can be referenced with the video again.
Perfect. Regarding operating systems and versions, also someone asked if it works on Rhino 6 for Mac.
Yes, it does.
Yes.
So we have not tested fully on all platforms, obviously, and we're looking for any sort of feedback. So if it does not happen to work on your certain setup, please send us your requirements and your machine setup, and we'll work diligently to get that working. But as far as we know, it should work on Rhino 6 and 7 for Mac and Windows.
Perfect. And Andreas Psar says, hello, everyone. Is there any way to control the plugin via scripting like Python?
It's a good question. I would say, so not at the moment, no, there's not. But going forward, when we release Grasshopper modules, there is potential that we will have some access to scripting within those modules.
Okay. Then Gökhan Belek also was, he missed the first part of the webinar. But again, right after it finishes, it will be available on our YouTube channel. Actually, the same link you are using right now.
Great.
Okay, then Aaron Porterfield asks, what happens when you thicken member lattice?
It adds a thickness. So here's a thickened structure that we made with our own thickening logic. And it is essentially our own pipe command that we've written. And again, just adds thickness to the curve.
Okay.
And that's a good point as well, as something I was showing before. If you wanted a structure for whatever reason, if you didn't want to use our thickening logic, or you just wanted the curve network, or you wanted to thicken later, you can always come back and let's say we'll just do a quick member network here and hit generate, and not a fan of the T. We'll just hit generate, and then I'll put my thickness to 0. And when I hit done, we'll get a curve network that you now can thicken, or use the classic Rhino pipe command. Let's see what that will do round. And you can get probably a very similar result as well. Yep.
Okay, I hope this answers Aaron's questions.
Yep.
And what else? Okay, thank you from many people, from Domenico, from Italy, I guess, from Yassin Turedi, from
No, I apologize. And something to sort of, when I was going over the export processes, again, being able to import, pretty seamlessly as mesh or a step or parasolid file, whether it's into a slicer or into FEA, that's our next step. So these are our design tools. Our next step are our optimization tools. And to be clear, we'll never create our own optimization tools. We're working to identify FEA partners so we can take these results and then plug them back into GL Studio and then have the structures be optimized accordingly.
Which ones do you use? Which FEA softwares are you using?
So I have recently just been playing around with SimSolid, and since our structures are of complete VREP solid data, the results in workflow are shockingly fast and simple. I simply just imported this as a step file and constrained the 2 planar faces at the bottom, and added a pressure load on the BREP faces that I clicked. And again, the speed at which you don't have to optimize your mesh, and then don't have to do painful mesh face selection for placing your loads and constraints is truly an exciting workflow, as many know that up to 80% of FEA is actually geometry preparation, and we're really aiming to eliminate a large part of that. Wow. With some key FEA players.
That's really cool. And of course, if the geometry comes from Rhino directly as a solid, it's great, because as you said, you don't need to prepare it before doing the analysis. Very cool examples.
Thank you. And here's a member pad, which is really exciting to us as members, people. It's very difficult to get a single solid member structure, and we've had a lot of results, a lot of awesome results. So we're very excited to see what people can do.
Mm-hmm. Okay, more comments and questions. Jakub says, okay, you have people even in Poland. Of course, we have people everywhere.
Great.
And Miguel Puebla asks, what's the difference between General Lattice and generative design from Autodesk? That's a tough question.
From generative design from Autodesk? That's a good question. Yeah. So basically, at the highest level, we sort of believe that I have a background in product design engineering. And so, I always, I try to create things that always, not only function the best they can, but, always, if you can add an aesthetic side to it, why not? And so sort of generative design, how it works is you're sort of just putting in a few inputs and you're saying, you're at the mercy of one person's algorithm, and you're saying, hey, see what you can come up with. But what's really interesting to us is that what if you could give a level of that sort of optimization back to the design engineer? And so with GL Studio, what's exciting to us is that now the design engineer can sort of purposefully explore shapes that they may not have been able to, create so easily before, but then, purposefully create shapes that now can be passed to simulation, that can now be validated, and now you can take that data to optimize. So instead of, again, having a single algorithm come up with your structures for you, is there a way to sort of achieve the same result, but by having more of a purposeful input?
And inside your preferred software, inside Rhino.
Correct. And so, and that's a good point. Is again something we really pride ourselves on. Is anyone that has tried to do Lattice NPD, it can be very difficult in many reasons, from software to the amount of iterations to getting those iterations printed if that's what you're doing. And so, just the ease of the workflow is really exciting to us because you can now explore, thousands of iterations very quickly. Again, all inside of your own CAD software. If you're using an external latticing program, every time you need to make change to your CAD body, that's an import-export process that is very costly.
Thanks for the explanation. Tim Downing asks, when do you think the full version will be launched?
That's a great question. I don't know if I can give an answer to that quite yet, but hopefully in the next month or two.
Okay. And well, it's not the next questions, but as it's related, one guy was asking if the beta will be free of charge for lifetime. Or I guess it will finish at one point, right? It will expire at one point.
So again, please don't hold me to this as, we are trying to navigate here, but as it sits now is there will be a lite version. The lite version of GL Studio will, as it sits now, include the design tools. So Lattice Loft, as you just saw, and our packages coming to be released, such as that optimization, as I was speaking about in manufacturing, those will be part of the full version. So again, as it sits now, GL Studio design package will be in the lite version, which will be free.
Oh, very nice. What's his name? Bala Diseño, I guess it's a nickname. He says, he asks if it's possible to vary the thickness in the model in different places. So I guess he's asking for variable thickness during
no, great question, great question. So as the beta sits, we just have a uniform thickness across. The next release will have varied thickness.
It's on the wish list. Nice.
Yep.
Then Arya asks, what's the best way to use this? Well, to use Lattice General in architectural structures?
It's a great question. We have done some exploration of creating some wall-like structures and facades and things like that. How the tool, again, depends on what you're trying to do in the geometry, but something we've sort of seen that is somewhat common is, some sort of wall facade that can be maybe printed on a large FDM machine or something, that is pretty complex. And so let me see if I can just sort of replicate that really quick. I guess my short answer would be is break your model into surfaces that the areas you want to be latticed, and then sort of work from there. And so I'll just do extrude curve here to create this sort of facade. Do something like this. I'll just do a quick copy and paste. And maybe do a rebuild. Just do 4s. And we'll turn the points on. So, if one could imagine this as being sort of a decorative wall facade potentially, maybe something odd like this, and you could use Lattice Loft. And, sort of start to explore what something odd like this may look like. Again, I don't really know what your geometry is like, but again, the biggest high level hint I can give is to really use your model optimize your model for GLS is to designate those zones you want to be latticed, and then rebuild that geometry or those zones you want to be latticed as single surface data.
Okay. What else? This is a bit long. Aaron Kostic says, hi, how do I wrap a custom shape around a cuboid where I just want the front view only, as a shape is different from every side? Just want the outer lattice around the cuboid and hollow center.
Oh.
So he wants to wrap a custom shape around a cuboid.
Interesting.
And only see the front view.
Well, let me see if I can try something here. So if I'm understanding somewhat correctly, I believe it may be like putting a lattice like around this shape here, like on the outside potentially, if I'm understanding. And so I'll just copy and paste this again, and I'll just scale it ever so slightly. I'll do the Lattice Loft, and let's see.
So at the end, you always need 2 or more open surfaces or 2 or more closed surfaces, right? And then.
Yep. And again, so something to note, thank you for bringing that up. This is Lattice Loft. We are really excited to release our whole suite of latticing tools, just like solid commands or surface commands. You have extrude, network surface, loft, offset. We plan to do that for all of our voxelization, Neubs, voxel modeling tools.
Okay. We will be fast with the next questions because we have only 5 minutes left. Remember that you can find Marek's contact details on the food4Rhino app page, so you can contact him at any time and maybe send him examples, etc. Or error messages like this one reported by Sanjay Yadav, that he says that sometimes it shows an error. A surface must be rebuilt to match UV count.
Yep.
Why does it show? That's, well, Marek was explaining to me that the UV coordinates need to be aligned, right?
Yep. So that's a great question. I'll cover that really quick. I would say that if you go to our video page, that I should have here, that's under on our support page and under our manual. If you go to videos, on input data criteria, this will answer all of your questions, maybe just to save a bit of time on the webinar.
Okay, it's one of the frequently asked questions.
Yep,
right?
and again, this
it's
is
basic for
Rhino. I would say is a lot of commands need to have matching directions and matching UV data, and so I believe that this should cover any questions. And if you still have some more, feel free to drop a line.
Perfect. So thank you from Croatia. Also thank you and greetings from Tanzania. Wow, I hope we could be there. And yeah, Nosdov, well, that's a strange name. He says, I would like to make a flexible hinge. Do you have an idea how to do that? Like an A-ware hinge.
Interesting. If the hinge would be the lattice itself, again, I would, think of everything as surface data. So for example, if I were to make a hinge that the lattice were to be the hinge, you could create almost, something like this. Oops. So, and then we'll just do extrude curve. So we'll have a surface here. And maybe we just extend it a bit this way. Great. And then I'm just going to copy and then paste that surface. And then I'm just going to move that surface this direction and might scale it down a little bit. Okay. And so again, this is quite crude, but we'll see what this does. And so this is actually a good example of the data getting crossed. That should be covered. But I guess a hinge for the sake of time, my best answer would be prep your hinge model as if you were preparing it for surface data. And whether it's going from this profile to the other profile or going from this direction to the other is there's multiple ways to go about it.
Okay. One more question, and this is also maybe a bit tough. Why should we use this tool instead of Crystalon? I guess you know about Crystalon.
Sure. So that's a great question. So we really aim to democratize, to make the creation of these lattice structures very fast and seamless and easy for someone that may not want or need to go explore Grasshopper. That's one option. Two, with Crystalon, you cannot actually create the geometries we are creating for two reasons. One, we explicitly defined unit cells as true BREP data and spent a lot of time doing this. So this is true surface data that we have IP around. And then two, going back to Neubs Voxel modeling, our wireframe structures are created of complete curvature. So Crystalon uses twisted boxes that are made of planar sides. So we'll never actually match your geometry. And so we will always be mapped and have full curvature to our geometry. So I guess if I had to answer the benefits of GL Studio or creating solid BREP data, matching your true curvature, and should be a lot faster and easier.
Thanks for the explanation. We have Aaron Porterfield, the developer of Crystalon, also in the audience. I hope we could give him also the voice, but unfortunately we don't have more time, but hopefully we'll also organize some workshops, webinars with Crystalon. And then I think it's always a matter of different workflows, etc. I don't think there is one software better than another. It's kind of how you feel more comfortable, or
Sure.
or if you are used to Grasshopper or not, whatever.
Always tools for something.
Both apps are looking great, and we are very happy to have this ecosystem in Rhino. And this question, actually, I wanted to ask the same to you before. If you have tried Lattice General Studio with Scan and Solve, this is an FEA plugin for Rhino.
We have not. Again, I'm very excited. We're actively looking for FEA partners to explore in all domains, and all of the ones that sit in Rhino are on our list.
Okay. The person that asked that, feel free to try it yourself. I mean, you can have as many plugins loaded in Rhino as you want. And okay, at the end, you are working with VREPs, so it should work fine with Scan and Solve.
Yep.
Okay, this is an addition to Aaron's original question about the. Sorry, I missed it. Yeah, about if how well does your thickening method handle nodes intersection of multiple curves?
Of multiple
curves. I guess you have like your own piping, you said, right?
Oh, yes. So
how well does it work when there are intersections?
It's a good question. And so it's actually interesting. We've had varying success with the Boolean of our member structures, but something that's actually really exciting, let's see if I can pull it up really fast, is that McNeel has just released an incredible tool in sub-D Rhino 7, which is their multi-pipe. And when you feed our structures to multi-pipe, they create closed single bodies that can be converted to Neubs. And so
I don't know if it's already on the work in progress version, by the way, beta version since yesterday. I guess we will organize a webinar soon showing you the latest.
Sure. If I can I'll just quickly answer Aaron's here. We'll give some complexity to this shape really quick. And then we'll do our lattice loft.
Actually, Andre Cooper says it would be great to combine this plugin with T-splines. Okay, T-splines doesn't exist any longer, but there is sub-D in Rhino. And I don't know if you have tried it already, but it should work with Rhino 7 beta, right?
Yes, I'm using work in progress right now.
Work in progress.
But absolutely, there should be no reason. And so what we can do is we'll go down, we'll hit generate, we'll hit 0 at thicken to spit out the curve network. We'll hit done, and we now have a curve network, and we can do the multi-pipe loft, and we'll hit 1, and we'll cap ends on, we want curvature. And then you can see we have a network, and then we can go to convert to Neubs, and we'll hit OK, and we'll hit cell closed polysurface, and we now have a single closed strut polysurface, which is really exciting.
Oh, that's great.
Incredible.
That's really great.
So we're really excited again to FEA, which hopefully we can do another webinar here soon, but we have just found tremendous luck with this.
Very nice. Okay, and we are running out of time, but I think the questions are very interesting. 2 more. Well, Dominique Lemedin is asking if you have a rough idea about the final price of Lattice General Studio.
Again, I don't. I don't want to say anything, but as it stands right now, we're aiming around slightly over the $1,000 mark.
Okay.
And that would be a continuing yearly price. And
the goal now is that people download the beta and give you as much feedback as they can, also
correct,
in order to improve it. That's the important thing now, right?
Yep.
Now. And the last one, by Hugo Ventura, we can add XYZ cells and we can change the gradient, but what can we do if we want to change the gradient by sections?
By sections. I'm assuming he means like control each spacing of like each column individually. And I would say that would come in future functionality. And to address that right now, I would, instead of using an entire surface to go in between two, divide your surface into your sections. And so then you can have each section along, and so you can control them individually.
Perfect. Okay, it was a great webinar. Many thanks again, and thanks from all the audience. Please remember, you can always contact Marek through support@generallattice.com, and that we have already 3 more webinars planned for the 3 next Thursdays. We will do Plan B, Procedural Build, and Panther. So see you in 1 week. And again, many thanks for attending this webinar, and thanks to Marek, of course.
Yeah,
Thank you,
Carlos,
and have a nice day. Bye.